the 7-flute taps. Use the different cams, it'd be the number 26 cam or number 28 cam with the 5 or 7 flute, and we also have the cams for the left hand. You simply set the lip of the tool on the setting blade, pull back, you're in the right hand slot. As far as the clearance on these taps, you would set it at about 16 or 17 for taper lead, and for a plug lead about 12, and for bottom lead about 4. The angles you set the workhead at would be 152 for a taper lead, 145 for a plug, and 120 for a bottom tap. So now the tool is set. Let's bring the grinding wheel in. Ground it off, just let it spark out. And if need be, when you're done, you can also face the taps. You swing the head around so it's straight onto the grinding wheel, and then would take the cam off and spin it and face across the end of the tap. This is about regrinding the leads on the reamers. The reamers are generally just sharpened on the tip. As they become dull, it's necessary to grind them back to keep the reamer from cutting undersize. Use the number 8 cam for the 4-flute reamer, and number 10 cam for the 6-flute, and number 16 for the 8-flute. And also have corresponding cams for the left hand as well. So I have the number 10 cam on here to grind the 6-flute reamer. Load the reamer in. Chuck it back in as close as you can. Rotate the lip on the step of the setting blade and latch. Normally these reamers would be set anywhere from 8 to 12 degrees depending on whether you had a zero rake on your, like on a standard reamer, or whether you had a right-hand cut, left-hand spiral, you would have more relief, and then less relief if you had a helical spiral tap or reamer. So the angle you want to set at is a 90 degree included on most reamers. Again, since you don't use any oscillation in this case, you always have to set it 10 degrees to the right, so you'd set it at 100 degrees on the scale. Feed in. Grind off as much as you want and let it spark out. Then when you get done grinding the lead, swing the workhead over, take the cam off, and then spin and bring the wheel in to face the end of the reamer. If these reamers are in bad condition, they're badly damaged, it's best to cut the tip off first before you start the grind, eliminate having to grind so much off. I'm going to go over the grinding operation now for the countersinks. Initially I'll show this setup for grinding the single flute and also the Weldon type countersink with a hole through the center of it. To grind these, we use this attachment. This is a single flute attachment, and this we use in the Model 250A and the 380. It has two drops on this one cam. This is the B drop, which is 3/64, and this is the A drop, which is a 32nd. You would set it to one drop or the other depending on the size. The larger sizes use a higher drop, and also depending on the type of material that you're countersinking as to how much relief you're going to need. So we slide the fixture into the chuck, And in the back, slide in the drawbar. The collets we use in this are the Bridgeport R8 collets, so you're going to need a different collet for every different shank size that you have. So you tighten the rotating handle in the back, and then load the collet in the front. Set the lip, or actually the heel, the back end of the countersink, just a little above center line. And tighten the collet from the drawbar in the back. So that is giving you the relief here. The angles that you set up are, again, you're not using oscillation. Make sure you have that locked out of the head so the head is straight in. And you would always set them 10 degrees to the right of the angle that you're looking for. In this case, this is 82 degrees, so I had set down at 92 degrees on the scale. Just turn the handle in the back as you feed in. Just keep it rotating. Just do that until you've ground off enough. If it's badly chipped or damaged, you can also do the plunge type grinding. It's bringing the wheel past the tip of the countersink, feeding in about 5 or 10 thousandths, and then as you rotate, feed the grinding wheel across. The hole type countersinks are ground the same way, except when you're setting these up, you're setting them up so that the hole that goes through the countersink is parallel. So in other words, if you look down on it, you can see the edge of both holes through there, and as you set that in and then go through the same operations you did on the single flute countersink. I'll go over now the multi-flute countersinks. The 2, 4, 6, and 8 flute countersinks are all ground just using the regular cams here. In this case, I've got a 4 flute countersink and grind using number 8 cam. These are ground very much the same as a tap or reamer. The angle that you set it at, it could be either a 60, 82, or 90, whatever. For the 60s, you have to set it so that you're going on the side face of the wheel. You use the OD of the wheel for the flatter angles. Now, I'm going to set this out just to pretty much any distance you'd want. Set the lip on the blade, right hand slot, and setting up for a 60 degree included angle going on the side face, you would set this up at 110 degrees on the right hand side of the scale. Now your cam drops are not very high for countersinks, probably about 6 or 8. Switch on. Let it grind until it sparks out. Now for the 3 flute countersinks, when you're using the 250A or the 380, you have to keep in mind the fact that you're going to be using number 10 cam, and that is going to be pushing it in and out 6 times, so you may end up coming off cam a little prematurely when you're grinding the countersinks. So what you have to do is index back to the number 4, 8, and 12 slots and grind a little secondary and take the high heel off. It's very much the same operation as used for grinding the 3 flute core drills and also the 3 flute taps. Other things that you should know about the countersinks is that there are a lot of 4 and 6 flute countersinks that are unevenly fluted.
they'll have, say, a 6-flute countersink, and they'll have actually 3 groups of 2 flutes. And each group is evenly spaced, but there's not equal space between each individual flute. So those type you cannot grind here because the cam is working only on evenly spaced tools. This is the operation of grinding the countersinks on the Model 252. This is for the 1, 3, and 5 flute countersinks, and also the whole type deburring countersinks. This is a typical setup for a single flute countersink. You would set the lip of the tool right on the setting blade. Now you may have to pull the pin down below the setting blade and swing it out to set the lip, and then you can pull that back. In this case, I've got a right-hand slot for right-hand countersink, and I have number 22 cam on for putting the relief. The relief drops that you would use would be anywhere from 2 to 6 or 8, depending on how large your countersink is. The bigger countersinks have a higher drop on them. You use the number 24 for the 3 flute and the number 26 for the 5 flute, and they also have the left-hand cams that complement those as well. For doing the hole type or Weldon countersinks, you would simply position those so that their actual cutting edge, the leading edge of the countersink, is going to pick up roughly level with the setting blade. There's a large space on these where you're not on the cam, so the actual location is not too critical. Again, using about the same relief as you would with the other countersinks. This is grinding the ends of the end mills and also the counter bores. You grip the end mills in the chuck the way you normally do. In this case, so you're not using any cams and you're not using any oscillation. All you're doing this is an indexing head. There's 12 equally numbered slots on the workhead. So initially you want to set it up in the number 1 slot. That'll give you your initial starting position for grinding. And then you set the end mill in, you chuck it back in as close as you can into the chuck. And if your setting blade is beyond that point, you can swing it out to catch the lip and then bring it back. If you're even beyond that point, you have to pretty much set it level by eye out on a step. As this setting blade is set on center line of the chuck, so that when you do that, you do have your end mills on center line, so they're set level, ready to grind. The angle that you set the workhead up depends on how much of a dish that you want to put on the end mill. If you want it perfectly flat, in the case you would on a counter bore also, do that. You would set it so that the pin is dropped in the center hole position, and that locks it straight in. And you would set up for a dish, you would set it up 1 or 2 degrees off center. So for 2 degrees dish, you want to set it up at 166 degrees on the right hand side of the scale. And then lock it in position in the front. Now to grind your primary and secondary on the end mill, that's done by dropping the workhead down below center. Now in your manual there's a chart that gives the actual angle generated by a given wheel diameter and a given height setting on the scale. So this, I have a 7-inch diameter dish wheel, and to give a 25-degree secondary relief on the end mill, I would drop that down to 38 on the scale. Now, I recommend using a dish wheel or even a cup wheel because this has a small point contact area, and that will allow you to make a nice cool grind because you're going across a wide face. And also that'll allow you to gash the end mills using the same wheel and in the same setup. So I'll switch it on. Bring your wheel in till you touch, then bring it past the end mill and then feed in about 5 thousandths at a time. Bring it across till you're almost over the next lip. Then when you reach that point, you zero your slip ring on the cross feed, bring it back, and index. Now if you have a 4-fluid end mill like I have here, you would index by 3s, since there's 12 equal positions. A 3-fluid you go by 4s, and then the 6, on the 2-fluid they're 6 apart, the slots. Feed it back to 0. Go to 0. And that grinds the secondary. The primary, with this wheel diameter, if I want a 5-degree primary, I'd set it at 8 below center on the scale. And again, I just feed it to 0. Now to gash the end mill, what I would do then is leave it in the same indexing positions. In this case, I want to loosen the lever, swing the workhead back on a 4-fluid. Now, if you had a 3-fluid or 2-fluid, you'd have to index back to get the gash, since the cutting edge is not in the same relationship as it is here. Now, typically you would set your gash at the same angle that you do your secondary. In some cases you want to have it even a little bit steeper. Gash one side, and then just keep indexing around. Each time you set your slip ring to 0. Now to thin your wheel out for gashing, it's best to use a small dressing stick and just narrow the wheel down to a small point. Depending on the size of the end mill really determines the size of the gash, and once you've done that you can use that for doing the facing the end and also the gashing. If you have an end mill that's very badly damaged, it is best to cut or rough it out first before you try to grind this, and even then you may have to do a rough primary grind to get the rough geometry there, and then go back and reset the tool and then go back and grind, because you do have a helix on the flute here, so as you grind down it's going to start to change the timing. Other things to keep note of the end mills is when you're using that thin wheel, don't use too much side pressure on it. You can chip the wheel off, in some cases even break it. And Other considerations are if you're using a center cutting end mill, that is, you have it gashed past center on two sides, you're going to have to do your gashing deeper on those two sides. This is the air bearing fixture. This is used for grinding the ODs and ends of end mills, as well as doing other OD grinding, let's say on reamers and also pilots on step drills. To put the air bearing fixture on and place the standard workhead, what you'll be doing is loosening this bolt down here, lifting off the old workhead, and putting on the air bearing fixture into here. There's actually a flat on the center post, and you tighten this back up. The components on the air bearing fixture, look at this side first. You have the finger assembly here. You have a micrometer height adjustment here and a lock to lock it in place, and also an adjustable finger that you can slide up and down. This should be set up on center line, so the very tip is on center line of your spindle. You also have, you can see there's a tilt feature here. If you loosen a bolt here, you can tilt the whole fixture, and the angles are engraved right on the top of this piece. You also have in the back an indexer. It has 12 equally numbered slots, and this is the index pawl here. It's spring loaded. Pin drops into the holes on the indexer. This you would use to lock your angle, lock your workhead into place. Turning the fixture around, you can see some of the other controls here. This locks the finger in place so you can slide it up and down the shaft, and this control moves the finger side to side. This handle here loosens the finger assembly and lets it rotate so that you can put on various angles on the tool, on the OD. This is a rocking mechanism. This allows the workhead to rock away from the grinding wheel when you're going from one flute to the next. And this is the fine infeed here. It's graduated in thousandths of an inch. That is of diameter. So actually, when you're moving this, you're taking off the diameter, not the radius of the tool. And here we have the air filter, and you hook your air line right up to this. And check that occasionally and see if you've got any dirt in that. Another thing you have to do when you initially get the air bearing fixture is you have to indicate your air bearing fixture into the slides on the machine. There's a 0 that a white scribe marked on the base. To indicate it in, you would swing the workhead around. The 0 lines up with the 0 on the right-hand side of the scale. Then lock the workhead in place. Then what you would do is mount a magnetic base indicator somewhere up here on the shroud or the spindle, and then move your slideway back and down along the edge of the spindle, getting that indicated true. Once you have that indicated in true on your pivot scale here, then you would mark your 0 point. That way you've got it indicated in so that when this is set at 0, you'd move it 180 degrees, you would be perpendicular to the wheel. This is the operation of end grinding using the air bearing fixture. First, what I've done is removed the finger assembly, taken right off the front, so there's all clear in the front here. Using the indexer here in the back, you would lock it in to one of the numbered holes. Usually we start in number 1 hole, and set the lip of your end mill so that it's level, the cutting edges are level, and then tighten the drawbar in the back of the fixture. For generating the primary and secondary and the gashing, that's done using the vertical motion of the grinding spindle. I'm using a 7-inch dish wheel here. That's what I recommend for doing this type of work, so you don't get too much of a radius in your tool, and also so that you have a thin section for gashing. So use the same procedure that you'd use for end mill grinding using the standard workhead. You would lower your grinding spindle down. In this case, to put a 25-degree secondary, I'm going to lower it down to 35 on the scale. I'm going to switch on. Come across to the opposite edge, then set your slip ring to 0 on the other end. And just continue indexing around, grinding all 4 sides, in this case on a 4-flute end mill. Now in doing the primary, lift it up to a higher number. In this case, we'll be grinding a 5-degree primary clearance. I bring it up to 8 on the scale, but the actual heights that you set this at, you're going to have to check in your manual. There's a chart in there, because the height settings for the given angles are going to change as the grinding wheel diameter changes. And for doing the gashing, recommend using the same angle that you use for doing the secondary. This is the OD grinding on the end mills. The spindle is set so that it's parallel to the grinding wheel. I recommend using a dish type wheel so that you have a point contact. If you are using your main grinding wheel, you need to set it so that your fixture is tilted at about a 10-degree angle, so you come across just a corner of the wheel, so you still have just a small contact area. The finger here is set up on center line so that when the end mill is going across, it's grinding relative to what you set here. You swing the finger, that sets the amount of relief. I'm going to set it now at 20 degrees to grind a secondary. Just set up there, and you also can set your stop collars so that you're not going to go beyond the end mill, or to make sure that you're going to grind all the way to the heel. The height of your spindle should be set on 0. That's on the center line. You position the edge of the grinding wheel so that it's just past the center point of your finger. That way, as you come off, you're not going to nick the cutting edge coming off when you come right off the finger. So I'll switch that on. Rock the fixture back. Bring the tool in. Then using your fine infeed, and until you contact the tool, and just draw back. Index, draw it back. Now to grind the primary, do is first move your wheel a little bit away. Swing that down to your primary angle. In this case, I'm going to use 5 degrees. Rock back, set it to